All right, so you guys remember from the video last night, the point of what we're doing today is we're practicing taking angles that were written in terms of like real world compass, like starting at north, thinking of that sort of thing. We have to convert it into a number that our calculator is compatible with. And then we also want to know, if we get an answer that our calculator is compatible with, how can we translate it back to answer a real world situation in a way that like normal people understand, as opposed to just like math people. So we're going to go ahead and write up here just to make sure that we remember the difference between the notation is that when I'm talking about standard form, that's what I mean for like the math version of like what's appropriate for your calculator. And if we recall this from the trig unit, when we were talking about unit circles and measuring angles and all of that, we always start at the positive x-axis, and we say that the positive x-axis is 0. And then we go counterclockwise around this way to find the rest of our angles. So that's standard. That's what's appropriate for your calculator. We always have to convert it to that before we can do the rest of the problem. And then if you're talking about real world situations, when they talk about measurements of things, one way they measure things is from bearing. And do you guys remember from the video what the start of bearing always is? It always starts at north, and it always goes clockwise around. So you could say bearing 5 degrees, you could say bearing 27 degrees, you could say bearing 312 degrees. You can do bearing all the way around. Okay, and it just means you started at north and went clockwise. So these are two completely different ways of measuring angles. Okay? And then the third way that people typically measure angles doesn't really have a name, but it either starts at north or south, and it could say starting at north we went a little bit east, or starting at north we went a little bit west. And these angles are always going to be smaller. They're going to be somewhere between 0 and 90. All right, because if I go past 90 to the east, now I'm talking about something that's south, not north. Okay, so these angles are always going to be a little bit smaller. So we're going to practice this because what we're going to be working on tomorrow and Monday before our test is making sure that we can take a problem now and convert the angles from this like notation that normal people use, convert it into math notation so we can solve a problem, and then convert it back so we can write the final answer. Okay, so that's what we're going to do. We're just going to practice it in a small piece today to make our lives a little bit easier. So we're going to do number 3 first. And the best way I think to do these problems is to draw a picture of what they're talking about and then figure out the way to write it in calculator angles. So they said to start at north and then go 45 degrees to the west. So starting at north, we're going to go 45 degrees this way. And so the calculator angle for that would have started over here and measured it like this. So what math could we do to figure out the calculator angle?
Plus 90.
Yeah, we could say 90 for the first quadrant plus 45. And that would give us the whole thing, which is 135. So the angle in standard form, the angle that would go into our calculator, is 135 degrees. All right, what if we did bearing 327? We're going to start off. We're starting at north, and we're going clockwise. So there's 90, 180, 270. Halfway would be 315. We're going further than that. So we went pretty far, right?
Wow.
Almost all the way back up to north again. So there's the 327 degrees. But to measure this for our calculator, we're going to start here and go this way. So how could we figure out what could we do? Yeah. Well, 90 and 45 would do the first picture real well, but we don't know that this right here is 45. So we know this whole thing is 327. How could we figure out that little piece right there? Yeah, we could do 360 minus 327. That would tell us the little piece that we didn't use. So if you do 360 minus 327, what do you get? 33. So that means that this little part right here is a 33-degree angle. So if we have 90 from the first quadrant and 33 degrees from that little part right there, then what do we have? 123. So then when we do the calculator version of this problem, we're going to go ahead and use 123 degrees as the angle that we're working with. Okay, let's try one more and then I'll let you guys practice these for a little bit. So this one says start at south and go 38.6 degrees to the west. So we're starting at the bottom this time because it says start at south and go 38.6 degrees to the west. So which direction are we going? Left. Yeah, we're going left. 38.6 degrees. Okay, you can check your folder. I think I put everything in there from today. Some of that stuff might be old, but you should take all of it. All of it's yours, so you should just take all of it. Yeah. All right, so if we're measuring this from the calculator, if we're going to measure this for the calculator version, how are we going to figure out what that is? Yeah, we could do 270, take away this part. So if we were to picture it, the whole thing would have been 270, and this is the only part we don't want to use. So 270 minus 38.6 is, you said it, but it didn't translate in my head. 231.4. That's what you said. Perfect. Now, that's not the only way you could have done this problem. So I've seen students say like, okay, the third quadrant has 90 degrees total. So that you could have done 90 degrees, take away the 38.6 and figured out what this little piece is right here. And then add it to 180. That would have worked as well. So there's different ways to do it. I'm not giving you a bunch of different little shortcuts because I think that these are easier if you just practice them and then learn how to think through it. And then you don't have to memorize like 6 or 7 different rules. Okay? All right. So go ahead and work on that. You're working on section 3 through 10. And then I will come back and I'll show you guys a couple of the 11 and beyond problems.
Do you want us to show how we got it? Like what was the
I want you to draw a picture just so that you can think about it visually. But you don't have to write the math that you are plugging into your calculator. But I do want to see a picture every time. Okay, so these problems are just doing the same thing but backwards. We're starting off with the calculator form, and we're converting it into whatever notation they tell us to convert it into. Okay, so for number 11, they said start off with 22.7 degrees for the calculator position. So 22.7 degrees is not very far. And then they want us to convert it into bearing. So for bearing, we start at north and we go clockwise. Yeah, we can do 90 minus 22.7, 67.3 degrees. Okay. All right. Let's look at number 12. So 213 degrees. And there are 2 blanks here because one blank is going to be the number And then one blank is going to be you figuring out if it should be west or east, because it'll have to be one of the two. So 213 degrees would be not quite to 225, which is right in the middle, so it's a little bit less than the middle. And so is this going to be on the west side or the east side?
The west.
The west. So we're going to say west. So the way that it measures, if we say south and then a degree measure and then west, is we have to start at the bottom where south is, and we have to see how far to the west it went. So we could do 270 minus the angle they gave us, and that would give us just this part. Say it again.
56.55.
So it is south 56.55 degrees west, which means start at south and go west 56.55 degrees. Okay. So anyway, let's go ahead and continue. This section goes until problem number 18, and then I'll have another couple examples to show you. Okay? All right. So this is one last formula. It helps you write a vector, and so here's the angle. That's whatever degree measure you're talking about. It needs to be in calculator appropriate degrees before you can write it into the vector. And then this right here, when we see the two bars and the V, what does that mean? Magnitude. So we have the magnitude multiplied by cos of whatever the degree measure is. That's the horizontal component. You can see because there's an I with it. And then sine goes with the vertical component, which makes sense, right? Because cos usually meant left and right, the horizontal part, and the y coordinate was always the sine part. So when we look at this, the magnitude for this type of problem is going to be the speed. So the magnitude of a vector can be speed in the case of objects that are moving when you're talking about their forces. It could be pounds of pressure. That would be a force like acting upon the ground. You can talk about newtons if you're taking physics, as in like something. I don't know. Anyway, so we have a plane is headed 32 degrees west of north. So first, we have to draw the angle and figure out what the calculator angle is so that we can work with it. And then after that, we're going to kind of plug stuff into this formula. So we're starting at north, and we're going 32 degrees to the west of that. All right, so we said that was a 122 degree angle from standard position. And so now if we're going to go ahead and write out the vector, we're going to say vector V is 536 is the magnitude times cos of 122 I plus sine of 122 J. Oh. No. It happens. It happens sometimes. All right, so we have this stuff written down. What do I do now to get rid of the parentheses?
Divide.
Not divide. Not add things up. Distribute.
Same letter.
Right. I know I said it.
Distribute.
You didn't say that.
Got one on the ratio. You gotta yell it next time.
Well, next time.
Put it on.
If you were looking at the problem and you recognize the angle as being one that shows up on the unit circle, then for this type of assignment you should simplify the problem. But when we're looking at this, 122 degrees does not show up on the unit circle, and so that means this particular problem is definitely a calculator problem. All right, so we're going to go ahead and grab our calculators. We're going to make sure that we're in degree mode. We're going to type 536 cos 122. So we have negative 284.037I plus 454.554J. And this makes sense because this is saying that your vector goes left and up. And if you look at what we drew, it does go left and up. So our answer is reasonable. All right, I want to look at problem 21. So a car is heading directly east. Directly east. It's not 90 degrees. It's 0 degrees. Yeah. So this right here is east. If they say directly east, they're not being like subtle. They're just saying, yep, it's 0 degrees. That's it. All right. Just like if they said north, they mean 90 degrees. If they say northeast, they mean exactly in the middle. All right. So when they say directly east, that means we're talking about a 0 degree angle. So if we go ahead and write the vector using the formula, we're going to say our magnitude is 68, and we're multiplying it by cos 0 degrees times I plus sine 0 degrees times j. And this is one that actually shows up on the unit circle. 0 degrees really is on the unit circle. So we're going to picture a unit circle. Here's our unit circle over here at 0 degrees. What's the x and the y coordinate right there?
0, 1.
0.
1, 0.
1, 0. Okay, so cos of 0 is 1. And sine of 0 is 0. So if you come across a problem where your angle measurement is something that is on the unit circle, then I would like for you to use the unit circle to simplify it as you go. Okay? All right, so we have angle V is 68 times 1i plus 0j, and then what do I do? Now I can distribute. So V is 68i plus 0j, or if you just wanted to say V is 68i, that would be fine as well.